Yeah.
Brilliant. So Maud is joining us today. Maud is a soil scientist at the UK Centre for Ecology and Hydrology, and we'll be talking to us today on improving soil conditions in response to notch creation and dune slack reprofiling wheels. So back to some notch. So thank you very much, Maud. Take it away.
Yeah. So thank you for that introduction. I am. So I work at the UK Centre for Ecology and Hydrology, and one of the projects I worked on was the Sense of Life project, which was led by Natural Resources Wales, and it was a major conservation project to rejuvenate sand dunes across Wales, and the main aims were to recreate natural movement in the dunes, and by revitalizing habitats which are home to rare wildlife. So I will focus on the two main interventions that were done, and then in relation to the soil monitoring in particular, the project looked at loads of things like changes in vegetation composition, the dune hydrology, and like all the way, like also including like animals and things, and all these reports are available or soon available on the NRW website or the project website, but I'll just focus on the soil monitoring part that I contributed to. So the two main interventions were dune slack reprofiling, that was done by the removal of vegetation and the soil organic layer to increase sand mobility, because the vegetated part was literally just gone to bare sand, and thereby also increasing opportunities for pioneer species. And then the second, there were notches created, and again to increase sand movement from the beach into the inland. So there were these were the sites that were part of the soil monitoring locations. So you can see a few of them up in North Wales and a few of them in South Wales as well. And then, so for the dune slack reprofiling, I have to say that there was pre-intervention monitoring and post-intervention monitoring. So both for the pre-intervention and the post-intervention, soil profile descriptions were made within the slacks, and then you also had intervention slacks and control slacks. And then also ring samples were taken from the surface 5 centimeter, 5 to 10 centimeter, 10 to 20 centimeter. And these were analyzed for bulk density, loss and ignition, electrical conductivity, pH, calcium carbonate, and carbon and nitrogen contents. And I'll just highlight some of the results. So this is the Pembrey example. You can see that soils, well, it's known that soils acidify and decalcify over time and become more organic over time as well. So by scraping off the organic layer, this resulted in lower LOI and lower nutrient contents and electric conductivity. And it also, as kind of expected, resulted in higher calcite contents, bulk density, and pH, because you basically just scraped it back to the more pure sand. And we found that quite consistently throughout all the intervention slacks. And then the results for the notch creation were a bit more varied. So what we did, we had controls transects and intervention transects with sand drain traps deployed at 50 meters, 100 meters, and 200 meters from the notch, and then also a controlled transect. These were emptied every 3 months to obtain seasonal and daily flux estimations. So literally what we did, we trapped all the material that was blown into the traps, assuming that most of it was wind blown. There were a few occasions where it was really clear that the trap had collapsed or that there was disturbance from like animals or things like that. So these results were, yeah, we did some quality assurance, and then yeah, so this is again an example for Pembrey. You can see quite a varied response in the bulk density. In this case, we didn't obtain the like what was expected was that the bulk density would be much higher at the 50-meter point in the notch transect, which is P1 in this case. PC is a control, and that then the bulk density would decrease with distance away from the notch, and also that the control transect would have a similar, well, kind of a similar transect with distance still, but mostly have lower bulk densities all over. As you can see, we didn't get that result, and this was quite varied for most of the locations. We also obtained high variability in sand fluxes across the sites. So again, what was expected was a higher daily flux in the intervention transect compared to the control transect, and also a decrease with distance away from the notch. So we did find this at Aberfrau, which was great, and also this was also a big difference compared to the pre-intervention. So that was a good result, but we didn't quite get that difference for the other locations. And you can also see the massive difference in flux amount anyway between the sites. And then, yeah, so there are generally no clear trends in daily flux or distance from the notch apart from at Aberfrau. We also looked at differences in particle size of the material obtained. There was quite a bit of unplanned disturbance that had an impact on these particle sizes. So that was quite difficult to separate these results. But what you're looking at mostly is you expect finer particles to be transported further away from the notch or from the source. So the mode of the finer particle sizes would be smaller, so more towards the left than the coarser particle sizes. But you can see that, especially at Aberfrau, the Aberfrau control transect, the material obtained was quite similar. And then even at the intervention transect, there were not that much differences in particle size, which could either imply that the winds were so strong that the material was just blown, was so strong that it could entrain more coarser particles as well. And then, yeah, you can see quite a bit of variation at Canvig in particular, where we think that a lot was just due to disturbance from either collapsed traps or other types of interventions that were not part of our design. So then, yeah, some take-home messages. The interventions have been successful in promoting sand mobility and altering soil chemistry in some areas, but not in others. This is to do to varying wind conditions, intervention skills, and the pre-existing geomorphology as well, which will have a big impact on the results of these interventions. So it's important to do repeated and large-scale interventions to gain more understanding of the effect of these. And also continuous monitoring is crucial to see how the effect of the interventions changes over time. So that was probably quite quick, but thank you for your attention. And yeah, I look forward to any questions.